Hello students, welcome back to Organic Canvas. Let's discuss the chirality of the organic molecules using the given example. So, what is chirality? Chirality is property of organic molecule which can rotate the plane of a plane polarized light due to the presence of asymmetry in the molecule. Say for example, when a carbon is attached to four different groups, say hydrogen, fluorine, chlorine and OH, that is hydroxyl group, then this carbon is called as chiral carbon. Since we cannot have a plane of symmetry in the molecule, it exhibits chirality and we can call this molecule as optically active. Why do you call it optically active? Because it can rotate the plane of a plane polarized light and its mirror image we call it as enantiomers. So enantiomers are the molecules with the same molecular formula and the same bond connectivity, but they are non-superimposable mirror images. So we call such molecules as chiral molecules, and if they don't have a chiral carbon and if they have a plane of symmetry, then we call that molecule as a chiral molecule. Students, remember, achiral molecules will not rotate the plane of a plane polarized light. Remember, chiral carbon is not the only character to define the chirality. It could be due to the presence of chiral axis. So what exactly is chiral axis? When a molecule like the cumulines are cumulated double bonds where the number of double bonds are even, like 2, 4, 6, etc. In these molecules, due to absence of plane of symmetry, so you can see that this carbon-carbon double bond and the substituents attached here, they are in the same plane, whereas here it is above and below the plane. So they are not on the same plane. So due to this, there is no plane of symmetry. So since this carbon is attached to two different groups and here the carbon is attached to two different groups, so the molecule doesn't have a plane of symmetry. So we call this as it has a chiral axis, and this is the chiral axis we are talking. That's why this molecule will be optically active. So this is a chiral molecule. Then let's check for the biphenyls. Here, due to the substrates at the ortho position, so we have nitro and methyl groups. So due to this, there is a steric hindrance. So the biphenyls will go out of plane. That means what? If all these groups are in the same plane and these three groups will be out of plane. So that means what? There is no plane of symmetry. Therefore, this molecule will be optically active. Nothing but this is also chiral in nature. Now, let's apply the same rule what we have used. The carbon is attached to two different groups. The carbon is attached to two different groups and they will be out of plane. Therefore, this also will be optically active. Whereas this molecule, although we have chiral carbons, what does that mean? This carbon is attached to CH2Cl, ClH and some bulky group. That means it is attached to four different groups. So we do have a chiral carbon here. Even then, this molecule will be optically inactive. Why so? Because there is a plane of symmetry within the molecule. When there is a plane of symmetry, there is a cancellation of rotation of the plane of a plane polarized light. That means the half of the molecule, if it acts as dextrorotatory, the other half will act as levorotatory, due to which there will be cancellation and hence the optical activity will be zero. Therefore, among the given four molecules, the fourth molecule, that is molecule D, due to the presence of plane of symmetry, the molecule is optically inactive, nothing but achiral. Therefore, the right option is option D. So students, to summarize, remember, whenever we have chiral carbon doesn't mean that it is optically active. Just check for the plane of the symmetry. If there is a plane of symmetry, it's optically inactive, nothing but achiral. If there is an absence of plane of symmetry, then there is optically active molecule, nothing but a chiral molecule. Thank you for watching this video, and if you still have any doubts on this, you can comment in the comment section. I'm going to help you with that. And please don't forget to subscribe the channel. Thank you.